Okay, so this question is asking us to make up a buffer, and it's saying that we need 300 mils of this buffer. Okay. Okay, so this 300 ml buffer has to be a 100 millimolar acetate buffer. And it has to be a certain pH. And now normally you would have to use the Henderson-Hasselbalch equation to work this out, but we've actually done the hard work for you, and we've told you that you need twice as much of the base form than you do of the acid form. Okay. So what we need to work out first of all is actually how many millimoles or moles of acetate we need floating around inside this particular buffer solution. So let's take 100 millimolar and expand this out. Oops, 100 millimoles per liter. And this 100 millimoles per liter, we don't need 1 liter of the buffer, we need 300 milliliters, which is equal to 0.3 liters. Okay, so we actually just need 30 millimoles of acetate inside this 0.3 liters of the buffer. Okay, so we've been told that we need twice as much of the base form. Okay, so base to acid, we need twice as much of the base form than we do the acid form. Okay, the base form comes in the form of this 0.8 molar solution of sodium acetate, and the acid form comes in this bottle of glacial acetic acid. Okay, let's start with the base because it's easier. Okay, so the base form, you know, you need 2 parts for every 1 part of the acid. Okay, so there's 3 parts all up, 2 parts are base, 1 part is acid. Now, out of the 30 millimoles, okay, floating around, so there's 30 millimoles of acetate floating around, or that need to be floating around in here. Okay, 2 parts of this 30 need to be base, 1 part needs to be acid. Therefore, we need 20 millimoles of the base form to 10 millimoles of the acid form. Okay, so the base form, the stock comes in this 0.8 molar solution. 0.8 molar can be expressed as 0.8 moles per liter. Let's bring this down to millis. Okay, so this is 0.8 millimoles per milliliter. Now, this means that from our stock solution, which is 0.8 molar, okay, so say this is contained in a flask like this, okay, if we take out 1 mil of this, okay, we're equivalently taking out 0.8 millimoles, okay, of the sodium acetate. If we take out 1 mil, okay, so 1 mil of the stock, we're taking out 0.8 millimoles of the stock. Do we need 0.8 millimoles? No, we need 20 millimoles. Okay, so 20 millimoles is in how many milliliters? Okay, so to get from 0.8 to 20, let's work out how to do that. This will be 20 divided by 0.8. Okay, so we have to multiply 0.8 by 25 to get to 20, which means we multiply 1 by 25 to get to 25 milliliters. Okay, so from this stock, we actually need 25 milliliters in order to deliver for us 20 millimoles, which is what we need for our base. Okay, so for our acid, what we need is 10 millimoles. The acid comes in this form, glacial acetic acid, very, very high purity, 99.7%. The density is 1.05 grams per mil. This is essentially the concentration. Okay, now because the purity is so high, 99.7%, we can almost just say it's 1.05 grams per milliliter. Okay, if you want to be absolutely precise, and again the discussion about significant figures and stuff comes in here, but if you had a purity of 70%, for example, you would multiply this 1.05 grams by the 70 or by 0.7 to account for the impure nature of this stock. But we have a 99.7%, which is essentially pure, so let's stick with this 1.05. Okay, in order to convert this 1.05 grams to an expression of moles or millimoles, we actually need the molecular weight of the acid form. Okay, so the acid form is CH3COOH. There's 2 C's in there, which means that is 24 plus 2 O's is 32, plus 4 H's is 4, which means the total of 60. Okay, so the molecular weight of acetic acid is 60, which means that 1 mole, okay, of acetic acid is 60 grams. Now, how many moles is 1.05 grams? Let's bring the calculator up. 60 divided by, whoops, let's clear that. 60 divided by 1.05 is equal to 57.14, and then 1 on that is 0.0175. Okay, so that's 0.0175 moles, okay, which is also known as 17.5 millimoles, is equivalent to 1.05 grams. Okay, so this 1.05 grams can be expressed in terms of the moles, and in order to do that we know this conversion here, which is 1.05 grams is equal to 17.5 millimoles. Okay, so 1.05 grams could be written as 17.5 millimoles, and the mils stays the same. So this means if I take out 1 mil of my glacial acetic acid stock, I'm taking out 17.5 millimoles of my glacial acetic acid, okay, or my acetic acid. If I need 35 millimoles, I'd take out 2 mils. Okay, if I need more or less, I'd take out equivalent amount. I don't need 17.5 or 35 for that matter. I need 10 millimoles of my acetic acid. And so 10 millimoles of acetic acid in how many mils? Well, to get from 17.5 down to 10, we have to divide by 1.75. And to get from 1 down to this, again, we do the equivalent calculation over here. 1 divided by 1.75. 1 divided by 1.75 is equal to 0.571, roughly. Okay, so this is 0.571 mils. Okay, so this means that to get 10 millimoles of my acetic acid, I need to use 0.571 mils of my acid stock. Okay, and so to make my final acid, I need 0.571 mils of acid stock. Okay, I need 25 mils of base stock, and the rest of it is just water. And this will make up my 300 mils of acetic or acetate buffer.